I'll say good afternoon because it is afternoon. I'm never sure it's the best to be right after lunch or right before lunch because you never quite know what the audience is going to want. But anyway, I'm here to talk about our smart community initiatives in Gwinnett County. I'll specifically get into the things we're doing with the grant. First, I want to introduce some folks with our team. I've got Alex Hoflick, who's our Traffic Engineering Division Director, Ken Keena, who's our ATMS and ITS Section Manager, and then with AECOM, we have Leslie Langley and Mark Start, who are assisting us on the process. We have a little bit of background about our system in Gwinnett County. I'll talk about our Connected Vehicle Technology Master Plan, which is the focus of the grant. And then I'll talk a little bit about our future, which is the Peachtree Industrial Smart Corridor. Real quickly, this is a map of Gwinnett County. You can see a lot of green and orange lines and a lot of dots, and that represents our ATMS and ITS, our traffic management infrastructure. That's 722 traffic signals. Of those, 550 communicate with our traffic control center in Lawrenceville. The system's supported with over 230 miles of fiber optic cable. We have 260 cameras for monitoring traffic real time, and then we also have 220 flashing beacon locations. The majority of those are for school zones. We just recently, in 2016, completed a project to upgrade those to the Internet of Things. So each one has cellular communications, and we also have real-time monitoring of our school zones. The system continues to grow. The orange lines I'll speak about a little bit more are our expansion projects. We issued notice to proceed to our contractors to start construction on these. These are on high-traffic corridors in the county. Result will be another 29.5 miles of fiber cable, 55-mile new traffic monitoring cameras, 31 new traffic signals connected to the system, and those are along 4 corridors. Ronald Reagan Parkway is number 1. That stretches from Pleasant Hill Road to State Route 124 in Snellville. It crosses Five Forks Trickham Road, which is number 2, and that goes from Rockbridge Road and to Sugarloaf Parkway. And those 2 projects provide much needed redundancy in the southwest part of the county. There's also Old Peachtree Road in the north central part of the county, and that connects from Sugarloaf Parkway to Dean Road. And then lastly is number 4 is State Route 316, and that starts at State Route 20 in Lawrenceville and goes out to the county line. Next is I'll give an overview of the project, which is our master plan for connected vehicles. It's funded by both this grant and from SPLOST funds. It builds upon our 2017 update to our ITS master plan, and which talked about connected vehicles. This just gives us a chance to give more in depth and to really analyze and determine the future for this in the county. We include some safety benefit research, which Dr. Gwinnett will speak about later. And there's some key goals, recommendations for standards and practices for connected vehicles, to have measurable outcomes for these projects, and then also to make sure it's replicable both in Gwinnett County and to other local governments. The project will have a 5-year planning horizon. We'll have stakeholder engagement throughout this process. The master plan, not 5 years worth. We'll have a deep dive on the best practices, the current technology solutions, and then the technology solutions that are going to come in the next 5 years. The federal government has not mandated a standard for the automakers, so things are going to be in flux until there's either a standard established or the old VHS versus beta debate is settled, and we pick a VHS for connected vehicles. Another thing to keep in mind is that this product has to be replicable and implementable. We don't want to put something on our Peachtree Industrial project that we can't expand out in the rest of the county over time. Another interesting part is how technology is adopted by people in this country. The standard rotary dial telephone was first introduced in 1876, and it took about 35 years before a quarter of the American population had a rotary phone in their house. Fast forward to when cell phones were introduced in 1983, and it took about 13 years before a quarter of the population had the same amount of, or 25% had cell phones. Now, of course, it's pretty much ubiquitous. Everybody has a cell phone. But one thing to keep in mind is for those agencies that may come along and want to use this plan later is that rates for rural adoption do tend to be slower for technology. That's historically documented. It's also current trends, you know, things like smartphones, tablets, other things that we take for granted probably in the metro area are lag behind in their adoption in rural areas. So we want to keep that in mind as we move forward. This is our project vision that was included in our grant proposal. The items highlighted talk about we want to set a standard for the application of connected vehicle technology. Certainly want to give props to folks that are involved with the North Avenue Smart Corridor and the things Georgia DOT is doing also with connected vehicles. But we want to try and take all those good things and add a few more good things and move forward. Obviously our goal is improve traffic congestion and reduce crashes. We'll talk about that in a little more detail. And lastly, as I said, we want to help agencies charged with traffic safety and mobility manage expectations, manage cost, and realize the benefits of these technologies. Not just us, but everybody that gets a chance to peruse our information here. So we have goals. These goals come from our comprehensive transportation plan process that we completed last year. You can see the things that are the priority rankings: vehicle travel, connectivity, transit service. But one of the big things, improved connectivity. And obviously that was probably geared more to connections between point A and point B, but also how we can connect our infrastructure to the drivers. We're trying to leverage this infrastructure to promote vitality and quality of life. And I'll touch on this one, improve safety and mobility for all people. We certainly, while Gwinnett County is a bedroom community, has a lot of commuters that drive into and out of the county every day, we do want to take into consideration those users that aren't using a car, those folks that are walking, biking, and then transit is a whole other conversation. So you can see the timeline. Obviously we're here today at our kickoff meeting. Tomorrow's the Connect ATL event, and then we've got the other upcoming workshops and then the community visit with the team. So here's our approach. We're in stakeholder engagement. We've met with Georgia DOT staff. We've had initial conversations with our public safety departments in the county. We're going to work with our cities and our community improvement districts or CIDs, see what they're interested in, and use their contacts to propagate this out to our public. There's a lot of different technologies and connected vehicle applications out there. Again, will it be the short-range radio, or will it be cellular in the future? We'll provide signal information. We're going to look at signal priority and signal preemption specifically for emergency vehicles, and again, pedestrian bicycle safety as we go forward. Freight solutions are also going to be part of the conversation in the future. There's quite a number of industrial areas in Gwinnett County. Again, the information for the road user. Will it be traffic signal timing? Will there eventually be delays? Where are the emergency vehicles? Where are they coming from? And all this is being done in preparation for our Peachtree Industrial Smart Corridor project. It's also a great opportunity for collaboration. Georgia DOT has got their SPAT challenge that's on State Route 141, which ends just outside Gwinnett County. You got the Regional Traffic Operations Program, which is about 200 signals in Gwinnett County, covers the entire metro area. GDOT has big plans to roll out more connected vehicle technology on those corridors. ARC's got their TSMO plan update. There's the GDOT managed lanes on A85 in Gwinnett County specifically. County just completed their Connect Gwinnett Transit Plan update, which was just adopted by the Board of Commissioners. We're also in the middle of, or just beginning the study of I-85 corridor. What are the opportunities there? Peachtree Corners has an autonomous vehicle shuttle, similar to the Chamblee project coming up. And then the county is also starting on a truck parking study. All these are driven by a need, and that need is the continued population growth. ARC just announced that the county's population was 910,000, give or take 100. Projections are that'll be over 1.3 million by 2040. We're going to continue to grow just like the rest of the metro area is going to continue to grow. So we're trying to, again, have these existing ideas, but prepare for the future. So I'll move into our Peachtree Industrial Project. Why did we pick this corridor? All the infrastructure in I'll turn it wrong. Then the blue area is Peachtree Industrial Boulevard. That's about a 1.5 mile swath on either side. The county maintains the road, the signals, everything in that right-of-way. We have activity centers and rural sections. It passes through 7 cities in Gwinnett County, and there's 16 in Gwinnett County now. So you can see we're touching about half of the cities in the county with this project. There are also 6 fire stations noted by the red dots that are within 1.5 miles of the corridor. So emergency vehicle preemption will definitely be a key component of the project. And this corridor is identified in the Connect Gwinnett plan for transit system expansion. The system's over 20 miles long. There's over 50 traffic signals involved. And you go from a 45,000 daily traffic at the south end of this corridor to 12,000 on the north end. So we'll get the variety of a somewhat urban feel versus a very rural feel. We're going to add the connected vehicle technology. We'll be broadcasting signal phase and timing data, so you can see when the signal will turn green, when the signal is going to turn red. There'll be safety messages. Perhaps you might be about to run the red light. It'll broadcast that information. We'll also be using adaptive signal control. We currently run a traffic responsive, which means it looks at volumes and then brings in a different timing pattern. Adaptive tries to be more predictive and be in front of that. It'll be a good way for us to compare these technologies and determine how we want to expand or just stick with traffic responsive in the future. Again, we'll provide the fire and EMS vehicle preemption. We want to reduce response times for those stations, first on PIB and then hopefully throughout the rest of the county. We'll look at transit vehicle priority to keep buses on schedule, so folks that are using transit can be on time just like folks try to drive their cars and stay on time. And then we'll want to provide road users, drivers, pedestrians, bicyclists, with information via mobile devices or an in-vehicle platform. That wraps up what I have, and I will turn it over to Dr. Gwynn to speak about the safety part of the project.
All right. So well, let me go back to one of the points that our keynote speaker made is the sensors don't make the city smart. It's what we do with the data coming from the sensors that makes the city smart. So we have the deployment of the connected vehicle technology coming up, but there's 2 sides to the story. One is the infrastructure side where we deploy all the technology, all the sensors, but on the other side you have to have somebody to talk to, which is the OBUs, the onboard units in the vehicles. And as Tom said, means there is not a mandate yet. We don't know which technology will win. So while we're waiting for the penetration of the technology to come along and we reap the real benefits of the safety advantages of having the technology, like with the connected vehicle technology, you have the OBUs are sending out BSMs, the basic safety messages, out, which tells that I'm here. So all the vehicles know where the other vehicles are. So it helps in collision avoidance, which is something the autonomous vehicle technologies are also addressing. But anyway, I'm deviating. So what can we do with the technology that we are putting in right now? And that's where the signal priority or the signal preemption comes in. It's something that we can do right now, and we can measure what the advantages or the benefits were of implementing this technology. So we'll start with the research part of this project. We'll start with the bottleneck analysis. We will look at where the problems are. We'll identify where the emergency vehicles are getting stuck and where the bottlenecks are for the regular traffic as well. As the problem with these preemption technologies or the signal priority methodologies is that it tends to have a snowplow effect. So when you have your emergency vehicle go through, it does get priority, and the delay for that emergency vehicle is reduced. But what happens in its wake? What happens to the rest of the traffic? And so signal preemption and signal priority, both of them try to address that in a safe manner, so you don't break into the time allotted for the pedestrians. So you don't catch a pedestrian in the middle of a cycle and run him or her over. So, I mean, but signal prioritization has been around for a while. But what we can do with the advent of these of the connected vehicle technology is, oops, did I go back? Is now we have the ability to know the path of the vehicle, or the vehicle is coming at a particular signal even before it comes to that signal. So earlier, signal preemption was based on the line of sight communication between the emergency vehicle and the signal controller. Now, with the connected vehicles, every signal in the corridor is connected. So you know 3 or 4 signals or intersections before that the vehicle is coming here, and you can flush the vehicles in front of the vehicle. You can prepare to give a green to that emergency vehicle even before it arrives within range of that vehicle. So we hope to look at some strategies of how to achieve that in the real world, how to really flush out the vehicles without completely disrupting the coordination on the corridor. And as well, we have done this to some extent on the North Ave corridor, but the challenges in this corridor is different in the sense that there is coordination along the corridor, and the Peachtree Industrial Boulevard carries a huge amount of traffic, but the emergency vehicles are mostly trying to cut across the corridor, so it's more disruptive than just trying to move the vehicle along the corridor. So, and so we'll have to look at the disruptive effects and how to address that, and that's where our research will be.